healthy and happy. Let's begin with today's topic. As you know very well, Bache, that we have been discussing the chapter number 3rd, that is electrochemistry. And in this topic, electrochemistry, I have told you that basically there are 3 main parts of this topic, this chapter. Okay, the first one was what is electrolysis, what is Faraday's law. Second one was the conductance. Second one was the conductance, and the lastly we have the topic. There is someone who's making it to you that in electrochemistry we have been discussed 3 main chapters, 3 main topics. Okay, the electrolysis, the conductance, and lastly we are left with the topic, the batteries. Okay, we have done all the previous topics regarding the particular topic. If I'm talking about the Nernst equation, that is super important topic, or I have told about the dilution law, that with the dilution the conductance changes, you know? And we have done some numericals also, they are super important. Okay, so lastly we are left with only the last topic, that is known to be batteries. Okay, but if I'm talking about the batteries, you have also studied this topic in physics, that battery is something which is made up of by combination of 2 or more cells. Okay, I'm repeating, battery is something which is made by combination of 2 or more cells in series. Okay, but basically what we will study here when we will start to teach, when I will start, we have 2 different type of batteries. Okay, and the first type of battery is nothing but it's just a cell. Okay, and basically it's a kind of galvanic cell. What is galvanic cell, Bache? You have studied electrochemical cell, that in galvanic cell the chemical energy is used to convert into electrical energy, है ना? All right, so this was all we have been studied about the galvanic cell, and I'm talking about that battery is the same process, that is the same type. Okay, but the point here is, if I'm talking about battery only specifically, so it must have some special points. The first point is it should be light, it should be compact, or it should be easy to use, and it must have a fixed potential, that is not so much variable potential. मतलब क्या है इसका? Not so much variable potential. See students, as I have told you that we are using our battery or cells so that we can get some electrical energy. हम batteries को या cells को इसलिए use करना चाहते हैं ताकि they provide us some kind of electrical energy, है ना? And if they are providing us some kind of electrical energy, that electrical energy must be fixed. That should not be so much varied. क्योंकि ऐसा नहीं है कि मैं चाह रही हूँ कि मैंने suppose किसी torch के अंदर अपने कोई cell डाला है, and for 5 minutes it's burning very strongly, it's glowing very strongly, and after 5 minutes its light has become dim, okay, due to variation in electrical potential. So that fluctuation we do not require in our daily life now. That's why we call that for a battery it must contain 2 to 3 important properties. Okay, so that's all about battery. We have introduced the topic. Now let's start. What are the different types of battery? The different type of batteries we have seen are only 2 types. First one is primary battery and second one is secondary battery. Let's start with the first topic, the primary battery. Why do we call it primary and what are its benefits and we can say disadvantage, its limitation. Okay, let's check out. Let's start. Okay, moreover, Bache, if I'm talking about the primary battery, this is all I have told you. Okay, now let's start. First of all, in our primary battery, the point is that the chemical reaction is started only once. Okay, Now, what happened in this particular type of primary batteries? My chemical reaction start only once. So whenever my chemical reaction has been started, it will exactly at the same time would start converting it into electrical energy. Okay, and after some time, after a long period of use, when my chemicals have been used up, the battery would become dead. That's it. Okay, so these type of batteries are like use and throw batteries. Okay, we just take them, the reaction has been started, we just put them, it would work for suppose for 2 years, and after that, when all its chemical have been used, all its chemical reaction has been completed, it's become dead and it's no more of our use. We cannot use it further. Okay, so these are the primary battery. The most important example of this battery is dry cell. This is also known to be Lake-Lenchay cell. Lake-Lenchay was the scientist who discovered this particular cell. So this is also known to be Lake-Lenchay cell. Now, the point is, why do we call it the dry cell? So the first point is, why do we call it the dry cell? Because the chemicals are in the dry form. That means not so much great liquid has been used. Okay, for example, if I'm talking about the electrochemical cell, when there was zinc and the copper, there was a solution of zinc sulfate and copper sulfate, which was in the liquid form. Okay, in here, the most cell are in the chemical form, in the dry form, but we would take them in little bit moist form. Okay, so that the formation of ions would be much easier. Okay, let's start. What is dry cell? Okay, now point is, dry cell is something which you use in your daily life in most of the apparatus. Okay, like if I'm talking about the remote, about the torches, about the wall clock, it's like a common standard cell जो आप लोग use करते हो. You use it for the wall clocks, for the remotes, you know, or many more examples. I have not remembered much. That is known to be the dry cell. Okay. Now the point is, in the dry cell, there is also, same as it is a normal cell, there is also two type of cell. So two type of electrode. One is cathode and second one is anode. This is known to be carbon rod, cathode, and this is known to be zinc anode. This is a common cell which has been partitioned, which has been separated, और हम उसको उसकी जो अंदर वाला part है वो आपको show कर. Okay, we have a metal that is known to be zinc. The whole body, the whole covering is made up of zinc and which behaves like an anode. Okay, in this zinc anode, there is a carbon rod which is known to be cathode. This carbon rod is covered with manganese oxide, and a moist paste of ammonium chloride. Okay, so nothing, there is a zinc anode, a zinc metal, a hole covering into which a graphite rod is over there. You can check it also. Just go in your after the class, if you have a normal cell, just try to separate it out. You will see that there is a complete covering which is known to be zinc anode, and there is on the upper side a red or something cap you would see. That is known to be your graphite rod, or we can say carbon rod. Okay, into it a moist paste of ammonium chloride and manganese oxide is over. Okay, now we have to see what are the types of reaction that are taking place in it. Since it is an electrochemical cell, it's a kind of electrochemical cell. So here the reaction, oxidation and reduction would take place. Okay, let's start with the first example. First of all, I have told you that at anode my zinc is taking place. So as an anode, the zinc would be oxidized, whereas at cathode, the carbon rod is over there, but manganese oxide and ammonium as cathode, because the reaction has been taking place only due to that particular case. Okay, so we have magnesium oxide plus ammonium chloride, and they would accept the electron and would make this kind of compound. We have some product. Okay, so manganese oxide, this is converted into, I don't know what's its name, we just write it. Now the point here is the oxidation state of manganese has been changed. If I'm talking about this is equals to +4. This is reduced to -2, -1, that is x minus 3 equals to 0, +3. The oxidation state of manganese is reduced from +4 to +3. This is anode, which is releasing the electrode. This is cathode, which is accepting the electron. So the half reaction has been taken place. We would combine the complete reaction, that is zinc plus manganese oxide plus ammonium chloride. That would become zinc 2 positive plus MnOOH plus ammonia. Okay, this is known to be complete reaction. And the point here is the zinc 2 positive and the ammonia, they have been combined to make a complex that is zinc ammonium. That is okay. So in this case, the reaction has been completed. One more point, the dry cell has almost an electrical potential of 1.5. Clear? So we have just studied the dry cell is something which has zinc and magnesium dioxide, and zinc as the anode is getting oxidized, whereas manganese oxide is accepting the electron, which is converting to manganese oxide. And this reaction is something, this cell is something which is just one way use. We will use it for some time, and after that time we have to throw it. Okay, that's it. This was the example of primary battery. Another example is mercury cell. Okay, as the name suggests, the mercury cell is something which contains the mercury as the main component. Okay, let's see, and we will see some the complete overall reaction of that particular cell. Mercury cell is something which is used in the torch, or we can say in the toys, in the batteries. आपने देखा होगा बहुत ही स्मॉल साइज की सर्कुलर फॉर्म में स्टील की जो सेल्स होते हैं, they are known to be mercury cell. Let's see. Since their size is very small, they're used in the small instrument like hearing aids, or I can say the toys, the watch, the now the components are mercury. Let's see what's the reaction over there. In the mercury cell, we have the amalgam of zinc metal. That is their zinc metal amalgam. That means zinc or mercury, they have been combined to make amalgam. And this reaction has been taking place in the form of anode, as well as cathode, there is mercury oxide. Let's see the reaction. Plus OH negative, it would make zinc oxide plus water plus electron. Same as it is if I'm talking about cathode, we have mercury oxide plus water plus electron, and it would convert into mercury plus hydroxide. Okay, so we have seen that in anode and cathode, both are mercury is present at some form, but the mercurous oxide is something which is present at the cathode, whereas zinc metal in the form of amalgam is present at the anode. Okay, this is also a primary cell, so it is also use and throw cell. We will just use it whenever the reaction would complete, it would stop work. Okay, so that's it, and that's all. We have just finished the topic. Now let's move with the second type, that is secondary cell. Okay. Oh yes, one more point, bache, I would want to say. the electrical potential of this is lower than the dry cell. This is 1.30. Okay, so its lifetime is also less. Now let's start with the secondary cell, the second example. Sorry, secondary batteries. Secondary batteries are those batteries which are rechargeable. Primary batteries वो थी जो one time use batteries थी, but the secondary batteries are rechargeable. How can they be recharged? We would just pass some current in the opposite direction so that its ions would start moving and it would be used to make electrical energy. Okay, now let's see what are the example of secondary batteries. There are large number of batteries, and most importantly, the secondary batteries are very bigger in size. They have been used mainly in the automobiles, like in vehicles, or like inverter batteries. Inverter batteries you have seen, this is known to be secondary battery. One more point, bache, in inverter battery, everybody has seen the inverter battery. You can see that there are many different type of cycles. Hai na? There are some different type of, we can say, blocks present over there. Okay, so the secondary battery is something which is combination of many cells. Okay, there are also anode and cathode present, but there are so many cycles, there are so many components which are present over there. And the most important example of this battery is lead battery. Okay, let's see what is that particular battery. Okay, bache, you have to between the primary and secondary battery, and the example, the reaction is not so much important in this case, but you have to go through them. Let's see. In the secondary battery, in the example of this, there is as anode lead metal, and as a cathode there is lead oxide, and that's why they are called to be lead batteries. Just we have seen in the mercury cell, there was anode like zinc amalgam, and the cathode there was mercury oxide. Same as it is in my anode, there is lead metal, and the cathode is lead oxide. Because mercury is something which cannot exist in the solid form, so we have taken zinc metal, but that is also present in the amalgam. That is surrounded or wrapped with the mercury solution. Okay, now let's see. There is lead metal, lead oxide, both are in the solid state. So how can we start the movement of ions? Because we know they need some kind of liquid so that the movement of ions would be easy. So we would use here sulfuric acid. Sulfuric acid has been used to make the movement of ions easy. Let's check out the reaction and then we would wrap up this class. At anode, there is lead in the presence of sulfuric acid, and it would convert into lead 2 positive plus 2 electron. Sulfuric acid here used as the medium to provide the movement of ions, whereas at cathode there is lead oxide plus sulfuric acid, and it would accept the electron and it would make lead sulfate plus water. The reaction has been taking place both at anode and both at cathode. And one more point, bache, I have told you that there are so many different type of plates. The inverter battery has many type of cells. Anode and cathode both are present over there, but in the presence of sulfuric acid. At lead, there is oxidation. At cathode, there is reduction. Okay. Same as it is in mercury cell, we have done the mercury oxide at the cathode and the zinc mercury amalgam at the anode. This is the reaction which takes place in the lead batteries. Now the point here is, I have told you that for recharging the battery, we have to convert them, we have to provide the current in opposite direction so that the number of ions would be higher and they would be start flowing the electricity again and again. So what would happen when we would reverse the direction, we would reverse the direction of current, my lead sulfate which has been formed over there. Okay, this is also lead sulfate. Lead plus sulfate has become to lead sulfate. Now, the lead sulfate has been converted into lead and lead oxide. That means my reaction was lead to lead sulfate and lead oxide to lead sulfate. This is now reversed and it has become at anode and at cathode. Okay, and sulfuric acid is present over there. So again, with the presence of sulfuric acid, it starts the same reaction. The cycle would continue and my battery would be recharged after some time. Clear? So this is how the battery, this particular battery is used, which is known to be secondary battery. Okay. Now, one more point, as we have seen in the primary battery, there are two examples, same as we will see some another example of secondary battery also, that is known to be chromium battery, but that is very expensive and we do not try to remember that, and we don't need to memorize the equation also. Just I want to say that in that particular battery, which is known to be nickel cadmium battery, which is little expensive than lead battery, and moreover this battery is very efficient because its lifetime is better than the lead battery. Okay, we're not going to check out the reaction over here. I'm just telling you that my cadmium and nickel has converted to cadmium oxide plus nickel hydroxide. Okay, so this is how we have done about the batteries, the primary battery and the secondary battery. We have seen that in primary battery, we can just use them, and whenever the reaction has been completed, we will throw them. On the other hand, if I'm talking about the secondary battery, they are rechargeable. They can be used again and again. We have seen some example, either it was in mercury cell, either it was in lead battery, or in the nickel chromium battery. Okay, so this was all about the batteries and the type of batteries. We will tomorrow's class start with the topic corrosion and the type and the fuel cell. The both topics are very important and very easy because you already know about what is corrosion and what is fuel cell. Okay, so in tomorrow's class we will see that. But in today's class, I have talked about the batteries and their types. And the most important point which I want to say, that this topic is comparatively less important than the whole chapter. Okay, so इसके ऊपर चिपकना नहीं है, ये सबसे important line है जो मैं बोल रही हूँ. Okay, this topic is quite less important than the whole chapter, but please go through them because we are in the board exam. No one knows how the question would become. Comparatively, you have to just check out what is the difference between the two batteries and what are the, we can say, most important conditions to being a battery. Like we have, it should be efficient, it should be light, it should be compact, and its potential should not be very good. Okay, we have seen only two questions in the previous years. One question was based on the dry cell, and second question was the difference between the primary and secondary battery. Okay, but just go through them and revise the topic. That's it. That's all I want to talk about this topic. Now, if there is any kind of doubt or query regarding this topic, please let me know. If there is any kind of doubt or query regarding this topic, batteries, type of batteries, please let me know.
Ma'am, I have a doubt.
Yes, bache. Please on your